Chapter 2, Section 8, Part 2, Dimensional Analysis. In dimensional analysis, what we're really doing is we're converting from one unit to the next. The key thing to remember is that when you convert from one unit to the next, you still have the same exact measurement. It just looks different in a different form. So for example, the first thing we're going to do is we're going to convert inches to feet. And when we convert inches to feet, hopefully we recognize and remember that 1 foot is equal to 12 inches. And so really what we're doing is we're saying, well, if I have a ruler and this ruler is 12 inches and 12 inches equals 1 foot, then 24 inches means I have 2 rulers. So that's kind of a physical way to look at what we're doing. But notice 24 inches and 2 feet, because that's how many feet I have, are exactly the same measurement. They're just talking about it with a different unit attached. And so when you convert from one unit to the next, you still end up measuring the same thing, you just have a different unit attached to it. And so the way that we do that is by using something called multiplying by 1. Okay? And so when we multiply by 1, that's the identity property of multiplication. And when we multiply by 1, we end up with what we started with. So if I took 24 inches and I multiplied it by 1, I still end up with 24 inches. Since 24 inches are 2 feet, if I took 2 feet and multiply it by 1, I should end up with 2 feet. And so why am I multiplying by 1? That seems like something doesn't make sense for me to do. Well, all of these conversion factors, feet to inches, miles to feet, pounds to ounces, gallons to quarts, inches to centimeters, all of miles to kilometers, all of these conversion factors basically equal 1. Just like 1 foot, as we see here, 1 foot is equal to 12 inches, it's basically like multiplying by 1. If I multiply by 1 foot or I multiply by 12 inches, I'm still ending up with the same measurement. And so how does that help us? Okay, well this is how it helps us. So if I start out with 24 inches, what I'm going to do is I'm going to multiply it by a fraction. And that fraction has to equal 1 because I want it to be the same exact measurement. But I don't want it to have the same units. I don't want it to any longer be in inches. I want it to be in feet. So that means I need to get rid of or divide away or multiply away this unit of inches. So what I'm going to do is I'm going to take this whole number 24 and put it over 1. So I have a fraction. And then, since my inches unit is in the numerator, I'm going to put my inches unit in the denominator. When I put my inches unit in the denominator, that's going to mean this cancels. But I don't want it to completely cancel because I want to end up in the units of feet. And since I have a direct relationship of 1 foot equals 12 inches, I can multiply 24 inches by the factor of 1, because they're both equal. Right? 1 foot equals 12 inches. And now that I've multiplied by 1, I still end up with the same answer. But what happens to my units? Well, here, this set of inches cancels with this set of inches. And for fractions, when you multiply fractions, you multiply completely horizontally. So 24 times 1 is 24 feet. Okay? So we're going to have 24 feet, but that's clearly not right. What do I still have to divide? Well, it's not 24 feet. It's 24 feet, 24 divided by 12 feet. And that gives us the answer that we always knew, which is 2 feet. I've now canceled out the units that I was in, and got to the unit that I had, and all I did was multiply by 1. As we look back at our original picture of the 2 rulers, I still have the same measurement. It just looks different with a different unit. So I only can multiply any of these numbers when I convert by 1. And that 1 just looks like the conversion factor. 1 foot is 12 inches, so I make sure that I put down 1 foot on one part of my fraction and 12 inches on the other. I want to, though, put the unit where it will cancel. So since I had inches on the top here, I need to have inches on the bottom here. Let's do one that's not as easy to do in our brain. So we have 29.5 inches, and we're going to convert that to feet. Well, I'm going to do exactly what I did before. I'm going to take 29.5 inches. I'm going to put that over 1. I'm going to multiply that by a fraction that's equal to 1. And since I want to get rid of inches, I put inches on the bottom. And since I want to go to feet, I put feet on the top. And the only reason I can put this here is because the conversion factor, there is a conversion factor for feet to inches. And so since 12 inches equals 1 foot, I have to put 1 foot on the top and 12 inches on the bottom. Inches cancel because I have inches divided by inches. And then I multiply straight across. So I get 29.5 divided by 12 feet, because that's the only unit that I have left. And when I take 29.5 and divide it by 12, that gives me what the actual conversion is. So I get and I'm going to actually round these to 2 decimal places just because we need to round them, because not all of them come out evenly. So I'm going to get 2.46 feet. And so what that's telling me is that 29.5 inches is 2.46 feet, which makes sense because if 24 inches is 2 feet, 29.5 inches should be more than 2 feet. And so all I did was convert from one unit to the next by multiplying by the fraction as 1. And then I still end up with the same exact measurement. If I were to measure something that was 29.5 inches, it would be 2.46 feet, but it looks different. So now I have another one, which I'm going from feet to miles, and so I do have a conversion for that. And so I'm going to write down what I have, and I'm going to let the units guide me. So I'm going to have 245.3 feet. I'm going to put that over 1. And I'm going to multiply that by my conversion factor, which, because it's a conversion factor, it means it's equal. So I want to get rid of feet, so feet go on the bottom. I'm going to let the units show me where to put my numbers. And I put miles on top. And so 1 mile, that goes on top, equals 5,280 feet. And I do exactly what I did before. I cancel out my units. I multiply straight across. And I'm going to get 245.3 divided by 5280, not feet, because I canceled out feet, miles. And when I do that, come up with 245.3 divided by 5280. And I'm going to round this one again to 2 decimal places, or 3 decimal places in this case. And that's going to give me 0.046 miles. In this case, I'm going from liters to centimeters cubed, okay? And so this one takes a little bit of a step. And so one of the things that's not written up here, but there is a rule for this, is that 1 liter is equal to 1,000 milliliters. And so what we're actually ended up with here is I don't have a direct relationship between centimeters cubed and liters. So that automatically tells me I'm going to need to use more than one fraction. But again, the fraction has to equal 1, so in each fraction can only go a conversion factor. And so I have 0.11 liters. I'm going to put that over 1. And now I want to get rid of liters, but the only conversion factor I have from liters is going to be milliliters. I could go to something else, but I have to kind of think. I want to end up in centimeters cubed, which means I have to go through milliliters. And since milliliters are also related to liters, I'm going to go from liters to milliliters, and then from milliliters to centimeters cubed. And that's going to allow me to get the right answer. So I do exactly what I did before. I know that liters need to go on the bottom, milliliters need to go on the top, because that's the conversion factor. 1 liter, it has to read properly, is equal to 1,000 milliliters. My liters cancel. But I'm not done here. I'm going to use my other conversion. And luckily, this conversion isn't actually that bad. It's pretty easy. Milliliters to centimeters cubed. So 1 milliliter equals 1 centimeter cubed. Milliliters cancel. And so now I end up with the unit that I was looking for, this one. And I multiply straight across and divide. So I'm going to end up with 110 on top, divided by 1 times 1 times 1 is 1. And so when I divide by 1, I get what I start with. I have 110 centimeters cubed. And so the clue in this problem is When you have units that do not have a direct right-of-way relationship, we're going to have to use what's called an intermediary, a middleman kind of say. And so we're going to convert from one unit to what's it's related to, and then use that unit to get to the end unit. In this, we have meters to inches, so this is a straightforward one because we have it's not a straightforward one again, so this has 2. And so we're in meters, and meters to inches. Well, meters don't go directly to inches if we have any conversions. No, meters don't go directly to inches, but meters go to centimeters. And so that requires us to know that 1 meter is equal to 100 centimeters. And so all we need is our conversion factor, and this will allow us to do this all the time. So we have 0.459 meters. I'm going to use my conversion factor. And I chose centimeters because centimeters and inches are related. So I'm going to go meters on the bottom. I have to put a 1 under here. And I'm going to go from meters to centimeters. And then meters are going to cancel. And then I'm going to go from centimeters, so I have to get rid of those, to inches. So that means 1 inch goes on top. 1 inch is equal to 2.54 centimeters. Centimeters cancel. I end up in the right unit. So I'm going to multiply 0.0459 times 100. And then I'm going to divide that by 2.54. And that's going to give me how many inches this is. And I get 1.81 inches. And all I did was multiply straight across, like I do with normal fractions, and then divide when I get to my final fraction out here. So what I really end up with is 4.59 on top divided by 2.54 inches, and that's going to give me this. Sometimes we don't have something that's only one set of units. Sometimes we have something that's 2 sets of units. And in this case, what we're looking at is a case that works just like that. And so we're going to have 34.8 miles per hour. And per hour means per 1 hour. So that's really what we're looking at here. It's called a unit amount. And so we have 34.8 miles per hour, so that's 34.8 miles per 1 hour. And we're trying to get to kilometers per minute. Well, what we're going to do is we're going to pretend that these 2 units are separate. And what we're going to do is we're going to set up our fractions to cancel 1 unit, and we're then going to set up other fractions to cancel the other unit. But we're all going to put these fractions next to each other because remember, each one of these fractions is a conversion factor, and each one of these fractions equals 1. So the first thing we need to look at is we have a direct relationship between miles and kilometers. That's good. And even though it's not written, we should know the direct relationship between hours and minutes. 1 hour is equal to 60 minutes. So I'm just going to do that. And so 1 at a time, I'm going to get rid of miles. And so 1 mile is equal to 1.61 kilometers. Well, that works because now I have kilometers on top where I need them. And so that will take care of the miles portion. Now I'm going to use a completely separate fraction to get rid of my hours. Well, since hours is on the bottom in this fraction, that means hours goes on the top up here. So that's 1 hour. And minutes go on the bottom. And lo and behold, that's what I need. So I got kilometers on top, minutes on the bottom. I have the units exactly the way I want them. And I multiply straight across. So I'm going to multiply 34.8 times 1.61 times 1, which is going to give me 56.028 divided by 60. And that's going to be kilometers per minute, because that's what I'm looking for. And then I'm going to put those together by dividing, and I end up with 0.93 kilometers per minute. And so we never try to tackle these problems all at once. What we do is we look at what we have, we look for our conversion factors to get to what we want. We set it up as a fraction, as a set of fractions that we're multiplying, and we use our units to guide where we put the numbers in our fraction. Since we had miles in the numerator, we had to put miles in the denominator to cancel, and since it was 1 mile, I had to put 1 next to the mile, equals 1.61 kilometers. That had to go on top because that one fraction has to be one conversion. That's this conversion. This whole fraction had to be this conversion. And again, we're using what we start with in the units to give us where we're going to put our conversion numbers.